In this video, the statistical description of data and graphics displays will be covered. For data processing to be successful, it is essential to have an overall picture of the data. The basic data statistical description can be used to identify properties of the data and highlight which data value should be used or treated as noise and outlier. We start with the measures of central tendency, which measures the location of the middle or center of the data distribution. So the most common and effective numeric measure of the center of a set of data is the arithmetic mean. Let x1, x2 up to xn be a set of n values or observation, such as for some numeric attribute x like salary. The mean of this set of values can be easily calculated arithmetic mean. In some cases, each value of xi in a set may be associated with the weight, wi, for I is equals to 1 to n. The weights reflect the significance or importance or the concurrence frequency attached to their respective value. This is called the weighted arithmetic mean or the weighted average. Effects of mean calculation. It is very sensitive to extreme values. Even a small number of extreme values can corrupt the mean. The solution is trimmed mean can be calculated. Mean obtained after chopping off values at the high and low extremes. Sort the values observed for salary. Remove the top and bottom 2% before computing the mean. Median. Middle value in a set of ordered data values. It is a value that separates the higher half of a data set from the lower half. If n is odd, then the median is the middle value of the ordered set. If n is even, then the median is not unique. It is the two middlemost values and any value in between. The median is expensive to compute when we have a large number of observations. The mode, the value occurs most frequently in the dataset. It is possible for the greatest frequency to correspond to several different values, which results in more than one mode. One mode means unimodal, two modes bimodal, three modes trimodal. Dataset with two or modes is multimodal. If each data value occurs only one, then there is one no mode. The mid-range. The mid-range can also be used to assess the central tendency of a numeric data set. It is the average of the largest and smallest values in the set. In a unimodal frequency curve with perfect symmetric data distribution, the mean, median, and mode are all at the same center value. Positively skewed data mean the mode occurs at a value that is smaller than the median. Negatively skewed data mean the mode occurs at a value greater than the median. Range, quartiles, outliers, and box plot. The range of the set is the difference between the largest and smallest values. The most commonly used percentiles other than the median are quartiles. The distance between the first and third quartiles is a simple measure of spread that gives the range covered by the middle half of the data. The distance is called the interquartile range and is defined as IQR equals to Q3 minus Q1, quartile 3 minus quartile 1. The 5-number summary, box plots, and outliers. The 5-number summary of a distribution consists of the median, that is called as second quartile, the first quartile, and third quartile, the smallest and largest individual observations, written in the order of minimum, Q1, median, Q3, and maximum. Box plots are a very popular way of visualizing a distribution. A box plot incorporates a 5-number summary as follows. Typically, the ends of a box are the quartile, so that the box length is the interquartile range. The median is marked by a line within the box, and two lines outside the box extending to the smallest and largest observation. Left-hand side, the data is given. Right-hand side, the box plot has been drawn. This is a solution for the left-hand side problem. A common rule for identifying suspected outliers is to single out values falling at least 1.5 into interquartile range above the third quartile or below the first quartile. To calculate the outliers very easily, IQR equals to Q3 minus Q1. We are going to test the outlier, find the IQR, then multiply the IQR with 1.5, then subtract Q1 minus 1.5 into IQR, then add Q3 plus 1.5 into IQR. Any value less than the value in step 3 or more than the value in step 4 is an outlier. Of n observations x1, x2 up to xn for a numeric attribute x is shown on the screen. The standard deviation of a set is a measure of how much a typical in the set differs from the mean. That is also shown on the splits include quantile plots or quantile plots, histograms and scatter plot. Quantile plot means a quantile plot is a simple and effective way to look at a univariate data distribution. First, it displays all of the data for the given attribute. Second, it plots quantile information. Second one, quantile plot. A quantile plot or QQ plot graphs the quantiles of one univariate distribution against the corresponding quantiles of another. Histograms. Histo means pole and gram means chart. So a histogram is a chart of poles. If X is nominal, such as automobile model or item type, then a pole or vertical bar is drawn for each known value of X. The resulting graph is more commonly known as bar chart. If X is numeric, the term histogram is preferred. The range of values for X is partitioned into disjoint consecutive subranges. The subranges referred to as buckets or bin. The range of bucket is known as a width. Two attributes X and Y are correlated. If one attribute implies the other, correlations can be positive, negative, or null. The scatter plot is one of the most effective graphical methods for determining if there appears to be a relationship, pattern, or trend between two numeric attributes. To construct a scatter plot, each pair of values is treated as a pair of coordinates, is an algebraic sense, and plotted as points in the plane.